Hello guys, this is the Med Dude and today we're doing Edexcel P1 2021. So let's get right to it. So question number 1, find the integral of 12x squared plus 1 over 6 root x minus 3 over 2x cubed, x to the power 4, giving each term in its simplest form. So the first thing we have to do is we have to convert these two terms into indices form. We do that because it's easier for us to deal with it and easier to integrate. So easier to integrate. So let's do that. So 1 over 6 root x, right, can be written, also be written as 1 over 6 x to the power half. And we can bring this power up into the numerator. It becomes 1 over 6 x to the power of negative 1 over 2. All right. So next we have the next term, which is minus 3 over 2 x to the power of 4, can also be written as minus 3 over 2. We bring the denominator, the x to the power of 4 up, becomes x to the power of negative 4. So those are our two terms. So now we can integrate, and this will be 12x cubed. So remember, so 1 over 6 x to the power of negative a half minus 3 over 2 x to the power of negative 4 dx, right? So now, well, let's integrate this. So how do we integrate? We add 1 to the power and divide it by the same number. So 12 x to the power of 4, 3 plus 1 is 4, and we divide by 4 as well, plus, so we're gonna keep the 1 over 6 as it is, so multiplied by x to the power of, so what's minus a half plus 1 is just a half, so a half, and we also divide by the same number, so a half minus 3 over 2 times, so we have minus 4, we add 1, becomes minus 3, so x to the power of minus 3 over 3 plus c. Now this is very important. Do not forget to add the plus c's because we don't have any limits. Add plus c. Alright. So now we can just simplify. So 12 over 4 is 3x to the power of 4. So now we have 1 over 6 and we're dividing by a half. That's the same thing as saying, multiplying by 2. So that'll be plus 2 over 6 x to the power of half, and then minus 3, I forgot the minus 3 over here, over minus 3, so minus 3 divided by minus 3, this cancel out, becomes plus 1 over 2 x to the power of minus 3 plus c. We can simplify it even further, and this will be 3 x to the power of 4 plus 1 over 3 x to the power of a half plus 1 over 2 x to the power of minus 3 plus c. So that is our final answer. We have integrated to the simplest terms. And there we go. That's the answer for question number 1. Let's move on to question number 2. So the question number 2 says, a curve has equation y equals 3x to the power of 5 plus 4x cubed minus x plus 5. Points P and Q lie on the curve. The gradient, right, the gradient of the curve at both point P and Q is 2. Now we remember gradient is also called our dy by dx is also called the gradient function, right? And they mention that the gradient at point P and Q is 2. So that means the gradient function is equivalent to 2 at point P and point Q, right? So what we can do is use that knowledge to differentiate and equate it to 2. Differentiate our equation and equate it to 2. So let's do that. So that will be dy over dx will be, so 2x to the power of 5 becomes 15x to the power of 4 because we take 1 away from the power and we multiply that power by 3. So 3 times 5x to the power of 4. Then we have 4 times 3, so that's 12x to the power of 2 or x squared because we took 1 away from the power, and x becomes 1. Right? Now this is equal to what? This is equal to our 2 that we got from earlier, from the question. So now we can simplify this. So 15, we can take 2 to the other side. 15x to the power 4 plus 12x squared. So minus 3 equals 0. Now, you can see here that all of these terms are divisible by 3. So let's divide by 3. So that will be, so 15 divided by 3 is 5. So 5x to the power 4 plus, so 12 divided by 3 is 4. So 4x squared. And 3 divided by 3 is minus 1 equals 0. So now we can solve it as it is, and we can imagine the x squared is now as x, and x to the power 4 is x squared. Or we can make it simple for ourselves, and we say let y equals x squared. And then now this becomes what? This becomes 5y squared plus 4y minus 1 equals 0. Now we can solve this, right? Quadratic equation. We can use a calculator, or we can factorize. Let's see if we can factorize it. I think we can factorize this. So this will now become 5y something, and then y, and we close the brackets, equals 0. So now we need to get a combination that gets 4y. So that's probably, we add 1 here. So we got 5y when we add them, and we need to get rid of 1. So minus 1. So when we get rid of them, we get 4y. So that makes sense. So what's our solutions? So our solutions are 5y minus 1 equals 0, or y plus 1 equals 0. So we get 5y equals 1, y equals 1 over 5, or we get y equals negative 1. So now remember, we need to substitute this back into these two y. So now this becomes x squared equals 1 over 5, and x squared equals negative 1. Now you can see over here, a square of some number equals negative value. So x equals square root of negative 1 plus or minus. Now this is an imaginary number, right? Imaginary number. Now this is not part of our solution, right? So we ignore this value. Ignore this solution, right? So now let's move on to our other solution that we can only get is x equals root plus or minus of 1 over 5. Now this is not in its simplest form, so now we can do root 1 over 1 is this one, root over 5, right? And this is the same thing as saying root 1 of 1 is just 1. So root 5. So this gives us root 5 over 5. So our x coordinates of P and Q are x equals positive root 5 over 5 and x equals negative root 5 over 5. So these are our x coordinates. So now we can just highlight them. So this is the answer. And it's important you state that you are leaving this. It's important you state that you're leaving this out because it doesn't exist. All right. So now we move on to question number 3i. All right. So we have 3 over x is greater than 4. I'll just do it over here. Actually, yeah, I'll do it here. So we have 3 over x multiplied by 4. Let's say it's greater than 4. So now we need to remember some key principles here, and we need to remember that we need for this type of question we need to multiply by x squared. So our solution does not change the inequality sign. So it does not change the inequality sign. So let's multiply everything by x squared, right? So we will get 3x squared over x is greater than 4x squared. So now we can simplify this. This will become 3x is greater than 4x squared. We can bring to the other side, becomes 0 is greater than 4x squared minus 3x. Now this is a quadratic inequality. Now how do we solve them? We need to first make this into an equation, not an inequality. So this will become, so 4x squared minus 3x squared equals 0. We take x as the common factor, so x, 4x minus 3 equals 0. So now we can now get the critical values. So now we're getting the critical values. Alright, so this will be now x equals 0 and 4x minus 3 equals 0. So 4x equals 3. So x equals 3 over 4. So these are our critical values. And now let's just rewrite this so it's easier for us to handle. So this will be 4x squared minus 3x is less than 0, right? Or the same thing as saying x, 4x minus 3 is less than 0. And we already have the two values. We have x equals 0 and x equals 3 over 4. Now, just by rule of thumb, if it's less than 0, you're always going to find x is in the middle and it's between two inequalities, right? So we take of this number, we take the lower numbers, that's 0. And over here, we take the larger number, which is 3 over 5 or 0.75. So that's our answer over here. All right. So let's go back to part II. So we're given a figure 1 that shows sketch, straight line L, infinite region R. So they tell us that it lies in quadrant 2 and 3, and given that this is gradient, so L has a gradient of 3, so in y equals 3x plus c. So we know that it has a gradient of 3. Line C has an equation y equals 2x squared minus 50. Okay. C and L intersect on the negative axis. So they intersect over here. So use inequalities to define the region R. So in order for us to do that, we need to remember what? We need to remember a couple of things, right? We need to remember that. So let's see. I'll just change color. So we need the values, the region. So we need everything below C. We need everything below C, right? That is out like underneath the curve. So we can already conclude that it's going to be y less than, I'm just going to write the curve for now. Curve. What else? We also know that the values are above, they're above line L, right? So the values that we want are over here. I'll change the color. So the values that we want are here. They're above line L. So it'll be y is greater than line L. We're gonna find what L is, and then we also know the values are also in this imaginary line, right? So this is probably an x equals value because it's vertical. So this will be it's less than this value. So I'm just gonna do we want these values. So you want these values. Okay. So this is x is less than a number, right? How do we find this number and how do we find L? We need to find this intersection. And how do we find that? We know that it intersects at the axis, right? Shown to us by over here, negative x-axis. So let's do that. So we have the equation y equals 2x squared minus 50. So now we equate to 0. So 0 equals 2x squared minus 50. So 50 go to the other side, 50 equals 2x squared. So we get x squared equals 25. So we get x equals either, so root of 25, which is either 5 plus or minus 5. So we're just going to say x equals 5, x equals negative 5. And now which one are we looking for? We're looking for this is negative 5, right? So we know that this value over here is negative 5. So we already have one of the region, one of the line that we need for our region R. So x is less than -5. Oh, is it less than or equal to? Now, if you remember, a solid line or a dotted line is when it's x is less than, or we can write a random value, or x is greater than a random value. Now, we also know that a straight line is when its x is less than or equal to, or x is greater than or equal to. So this will be a straight line, because you can see over here, this is straight lines. So we're going to less than or equal to over here. So our first, so I, so I'll just write here I. So one of the first lines we have is x is less than or equal to -5. That's our first answer, first inequality. Okay, so now we need to find what L is. We know that it intersects at here, so that point is what? It's -5 and y is 0. And we already know that it has a gradient of 3. So using that, we can now find the equation, right? So we can do y minus y1 equals m x minus x1, and we use the point -5 and 0. So that'll be, so y minus 0, which is just 0. So m is 3. This will be x, and minus -5. So this will be y equals 3, x plus 5. This will be y equals 3x plus 15. So we now know what L is. This is L, right? So this is our L. This is our L. So now we know this is also, we know that this is less than or greater than or equal to L. So now our second equation that we have is y is greater than or equal to L, which we said is 3x plus 15. Now what's our last line that we need to get? We need to have the curve. Now the curve is also the same thing as a solid line. So we have it y is greater than. Is it greater than or is it less than? It has to be less than. That's my math over here. It's the wrong symbol. This should have been y is less than or equal to. This is less than or equal to 2x squared minus 50. Because this is less than the curve. This is beneath the curve, right? This is beneath all the values. So all the values beneath the curve. Alright. So now our last inequality is y is less than or equal to 2x squared minus 50. So these are your three inequalities that define region R. Alright, so now we are going to move on to question number 4. So we have figure 2 show a sketch of the curve with equation f of x where cos 2x is and goes from 0x all the way to k. Now you can see this is in degrees, so this cos 2x, right? So we know that usually the intervals are usually at what? We have usually at 90, usually at 90, 180, 270, and 360. Now because this is 2x, we're going to get the same values at 45, 90, 270 divided by 2, which is 135, 360, this will be 180. So we'll get the same y values. We're going to get the same y values, just so we're clear. Okay, so now the question says point Q and point R, which is so point Q and R, right, lie on the curve. So state the coordinate of Q and the value of K. Okay, so we said that the values at 90 usually are now at 45. So this is 2x, right? So we know that this over here, when it intersects the 0, so this is 0, this is 1, and this is -1, right? This is -1. So this is what? This value over here is negative, so no, this is 45 degrees, 0, x, y. And so this will be, Q will be, so our coordinate for Q that we can write is 90 degrees at -1. So that's this one over here. So that's that. So now what's next? So we need R, because R is k is 0. So let's check. So this, if this was 90, So if this was 90, this will be 135 like we said, this will be 180, and this will be, so if we were to move on, this will be 450 over here. We add a 90, this will be 225, right? So R will be 225 degrees and 0. So the value of K is 225. So they just want the values, 225. So that is the answer over here. So part B, given that there's only exactly two solutions at cos 2x equals p in the region 0 less than or equal to k, which we know is 225 degrees, right? We know this is 225. Find the range of possible of p values. Now, what does it really mean? What does this mean? So if I was to just write this down in part B, they're asking for cos 2x equals p where there are only two solutions. Now what that really means is that you only pass, so this is the same thing as saying you only pass through 2 points. So through 2 points if you draw a straight line across the x-axis. So draw a straight line across the x-plane. All right, so let's look. So we need to find, so you can see over here, right, that if we were to draw a line just at -1, you can see there's only one solution, right? One solution. But as soon as we go above -1, there are how many solutions? There are two solutions. You can see it goes through twice. Anywhere between -1 and 0, it has two solutions, right? Two solutions. So we can say, right, this region here, P has how many solutions? So this has two solutions. So we have two solutions here. Okay, so what about everything above 0? So you can see everywhere above 0, if we were to draw a straight line, you can see we have 3 solutions. So we don't want this, right? Even at 0, until we reach 1. Now 1 has how many solutions? It only has 0 and 180. So that's how many solutions? 2 solutions. Right? So the range that we can say from this is what? So we can conclude and say the range is -1 less than, not equal to, less than, sorry, P is greater than -1, but it's less than 0. Now why is that? Because we're excluding -1 because we only have one solution here, and we're also excluding 0 because we have 3 solutions here. And the question specifically asks us to give exactly 2 solutions. So that's part of it. And then we all said and when p equals 1, we only have 2 solutions. So this is our range of possible values. All right, so let's move on. Question number 5. It's question number 5. So we have a line L1 has equation 3y minus 2x equals 30. And then we have, so I'm just going to highlight this so over here. And then we have L2, that passes through the point A, 24, 0, and is perpendicular, that's the keyword, to L1. And line L1 and L2 meet at point P. Okay. So find, using algebra, the coordinate of point P. Now we need to remember that perpendicular means, to L1 means, this will be what? The gradient of this will be, the gradient of this L1, L2 line will be -1 over the gradient of L1 will be the gradient of L2. right? So how do we find the gradient of L1? We need to make y the subject over here. Y, so make y the subject, so we can see in y equals mx form plus c, where this is the gradient. Yes? So now let's rearrange it. So we have 3y equals 2x plus 30. So y equals, this is for L1, right? So y equals, let's divide them individually. So 2 over 3x. So 30 divided by 3 is 10. So this is what we get, right? So now we know, so gradient of L2 will be, gradient of L2 will be minus 1 over, so what's the gradient here? The gradient over here is, I'm just going to write it here, is m of L1 is 2 over 3. So we can just write 2 over 3. So now this is equivalent to minus 1 over 2 over 3. So we take the reciprocal, we can times it by the reciprocal, so we will get negative 3 over 2. So now we have the m of L2 is negative 3 over 2. Now are we done here? We're not, because now we need to find out what? They pass through this point here, right? To find point P, we need to do what? We need to equate line L1 to line L2, so we can find the coordinate of P2. That's how we're going to find it, right? This is the key concept over here. When we equate both equations, we can find the y and the x's values, right? Or we can find the x coordinate, which will lead us to the y coordinate of P. So let's find the equation of L2, right? So we have y minus y1 equals mx minus x1. And the coordinate we're using is a at 24, 0, because L2 passes through this point, so it's part of it. So we have y minus, so you can see over here 0 equals m. M we're going to use which m? We're going to use this m over here, minus 3 over 2. So minus 3 over 2 x minus 24. Alright, so we will get what? We'll get y equals, so 0 stays as it is, so minus 3 over 2x. So minus 3 over 2 times minus 24, what do we get? So we get plus 36. Plus 36. So this is for L2. So I'm just going to box it. This is our L2. So now we equate them, right? To get point of intersection, we do at P, right? Obviously at P, we do L1 equals L2. So that'll be what? So we already know what L1 is. So that's 2 over 3x plus 10 equals minus 3 over 2x plus 36, right? So now we can just move it to the other side. So we'll have 2 over 3x plus 3 over 2x equal 36 minus 10, which is 26. So this will be equivalent to, so we'll have, so 2 times 3 is 4, 3 times 9, so we have 4 plus 9, which is 13, or you can just use a calculator, 13 over 6, x equals 26. Alright, so now what? So we can find what x is now, so x will be, so 13x equals 6 times 26, x equals 6 times 26 divided by 13. Now I know that 26 over 13 is 2, so x will be 6 times 2, which is 12. So we have the x coordinate, right? How do we find the y coordinate of point P? We can just substitute it back into any one of these equations. I will just, for simplicity, because I already have it here, I'll just sub it into L2. So we will get y equals minus 3 over 2, and we are subbing this value into here. So that will be times by 12 plus 36. So that will be so 36. That will be 18. So 36 take away 18. That will be 18. So our point P is 12, 18. So that's our 5 marks over here. Now let's take a point B. So given that L1 meets the x-axis at point B, find the area BPA. So what do we do? So we know, let me go here. So we have part B here. We know that point B, where did this happen? This happens when L1 meets the x-axis, correct? X-axis. So that's what when we substitute y equals 0, right? Let's substitute this. So we substitute this into the equation. So what is the L1 line again? So L1 is, the line is 3y minus 2x equals 30. This is from the original question. So when we substitute y equals 0, so we have 3 times 0 minus 2x equals 30. So we have, so this is just 0, so we have minus 2x equals 30. X equals 30 divided by minus 2, we get minus 15, right? So this is obviously at the x-axis. So what do we know? So now we know point B, which is what? Minus 15, 0. And we have point P, which is 12 and 18 from the previous question. And we have A, which is 24, 0. Now to better understand this, we can draw a diagram. So to better understand it, we can draw a diagram. Understand it? You can always draw a diagram. So always draw a diagram. It also makes it easier, obviously, if you have time, but it's always best. So let's draw the diagram. So let's just make it a big plane over here, and let's do it from here to here. As you can see, all our values are in the positive y plane. They're part of the y quadrants, so we can only have to draw the first two. So B is the negative 15. So I'll just do B's over here. This is 0. And then we have 24 is probably around here. 24, 0. We have negative 15, 0. And then we have P, which is around here somewhere. So if I draw it around here somewhere, and then so that's around about where P would be. All right. So now this is actually a right angle triangle because this was L1, right? So if you remember correctly, this was L1, right? And this is L2, and they're both perpendicular and they meet at P. So because they're perpendicular, they meet at what? They meet at 90 degrees, right? So this we know is 90 degrees. We know this is 90 degrees. There's no doubt about it. This is 90 degrees. So how do we find the area of a triangle? The area of a triangle is half times base times height, right? Times height. Now you can find the distance. You can do it two ways. You can find the distance from here to here, right? Distance here and then distance here, and we can time them together and divide by 2. Or the easier route, we know the distance from here to here and the height, which is here to here. So let's call this the height. So the base is 24 minus 15, which is plus 15. That'll be what? That'll be 49, right? Sorry, 39, not 49. 39. And the height we already know because of this, because it starts at 0, right? It goes all the way to 18. Because from P, we can see over here. So we have the base, which is 39. Then we have the height, which is 18. And we can just work out the area. So the area is half times 39 times 18 to give us 351 units squared. So our final answer will be area of triangle BPA is 351 units squared. So over here, this is our units squared. So that is the end of question 5. Let's move on to question number 6. So a curve has equation y equals f of x, where f of x is 2x plus 1 and x minus 3 cubed, x minus 3 squared. Sketch a graph of C. Show a graph coordinates where C cuts off or meets at the coordinate axis. So now we know we need to find out what kind of graph this is. You can see over here there's 1x here, and there's x minus 3 and x minus 3 again right here, if you want to simplify it, if you can want to get rid of the squared. So this will be a cubic graph, right? You can see x times another x will give us x cubed graph, right? So we know it's an x cubed graph. An x cubed graph has usually a shape like this, right? So we now know it's a positive x squared graph, x cubed graph. Now what about the roots? We know the roots are what? The roots are at -1 and roots are at 3. So these are our roots, which will meet the x-axis, right? What about the y-intercept? So it will be 1 times, so it will be 1 times my -3 times another -3, right? So 1 times -3 times -3. This is C. The y-intercept will be just +9. And we also times it by 2. We times it by 2, all of this, because there's a 2 in the beginning. So we'll get +18. So now we have everything we need. So now let's draw the graph, just using the knowledge we just acquired. So over here, I'm just gonna draw it a bit here, and then, oh wait, this is not straight. Whoa. All right. So and then we have the other graph, which is around about. Let's just draw it here. All right. So we know that it meets at what? -1 and 3. And because this is a squared graph, this x minus 3 whole squared, I know that at x equals 3, this is going to curve like this upward. It's not going to go below 0. So it's going to start from here, and it's going to go probably around here at 18 and -1. So we just have to draw a simple graph like this. So it takes a couple tries, but do it slowly. And this has to be a bit more curved. I'll just do a bit more curved like this. And this is around about what you want. And we have to now also label it. So this will be -1, 0. This will be 0, 18. And this will be our 3 and 0. So that's our part A. Part B says write f of x in fully expanded form. That's pretty simple. So I'll write B here. Now we know f of x, as they're saying, is 2x plus 3. Not x plus 3, sorry. X plus 1 times x minus 3 whole squared. Now we can go ahead and just do x minus 3 whole squared separately. That'll be x minus 3 times x minus 3. That'll be x squared. So minus 3x, and then multiplied by -3 times x will be -3x plus 9. We can simplify this to get x squared minus 6x plus 9. So now we can just write f of x is, so I can just go ahead and write, so that's 2x plus 1 times by x squared minus 6x plus 9. And that's the same thing as saying, so 2x plus 1, and oh, no, not x plus the same thing, so let's just expand everything. So everything multiplied by x once, x cubed minus 6x squared plus 9x. And now, so first we did this, and now we're doing everything multiplied by plus 1. So that'll be plus x squared minus 6x plus 9. And we're going to close the bracket. So now we take the like terms. So there's only one x cubed, so that stays as it is. But there are two x squared terms. So minus 6x squared plus x squared. So minus 5x squared. Then we have 9x minus 6x, so that's plus 3x. And the 9 stays where it is. Now we just have to multiply by 2 to give us our final answer, which is 2x cubed minus 10x squared plus 6x plus 18. So, see over here, we have, alright, so that's that. Let's move on. So the next question, we also have a part C. Part C says, find the equation of the tangent to C where x equals 1 over 3. Now tangent, how do you find the tangent? Now tangent means what? Tangent line. So I'll just write it here. So this is now part C. Now the tangent line, how do we get the tangent line? So this is what, when we need the gradient, at x equals 1 over 3. Why 1 over 3? Because over here they say they want the tangent line to C at point where x equals a third. So we also need the gradient at x equals 1/3. So how do we get this? How do we get the gradient? If you remember, dy over dx, right, was what? The gradient function, wasn't it? So all we have to do is just differentiate. So we had f of x, which was, from the previous question, is 2x cubed. So 2x cubed minus 10x squared plus 6x plus 18. And all we have to do is just differentiate it once. So differentiate it once. That will be, so 6x squared minus 20x plus 6. And what do we substitute? We have to substitute a third into this. So that will be 6 a third squared minus 20 times a third plus 6. Right? So that will be equivalent to what? That will be 2 over 3 minus 20 over 3 plus 6. So that gives us what? That gives us 0. So this is what? This is our gradient, right? This is okay. Gradient is 0. Okay, so this is our gradient. The gradient x equals 1/3. So now we have the gradient, which is 0, and we have the x coordinate, which is a third. Now we need the y coordinate at this point. So how do we do it? We substitute x equals 1 over 3. So that'll be what? The initial equation, 2 times 1 over 3 cubed minus 10 1 over 3 squared plus 6 1 over 3 plus 18. So that will give us, so 2 times 1 over 3 cubed plus minus 10 bracket 1 over 3 whole squared plus 6 times 1 over 3 plus 18. This gives us 512 over 27. So this is our 512 27. Alright, so now we have, I'll just write here, we have the point is at a third, 512 over 27, and we have our gradient as 0. So now we can use the equation y minus y1 equals m bracket x minus x1, and we just input the values. So y minus 512 over 27, gradient is 0, x minus a third, and so 0 multiplied by everything is just 0, so we have y minus 512 over 27 equals 0. So our equation is a straight line at 512 over 27. So our tangent line is, so this is our tangent line at x equals a third. So this is our final answer over here. You can also write that it's the equation of the tangent line at x equals a third. Alright, so then we can just also highlight this. So now this is the end of question number 6. So now we go on to question number 7. So figure 3 shows us the design for a sign at a bird sanctuary. The design consists of a kite, OABC, and it's joined at sector OXEA, and they tell us some information here. OA equals OC 0.6 meter, so we can just write 0.6 meters here and 0.6 meters here. AB equals CB, so that is 1.4 meters here and 1.4 meters here. Angle OAB and angle OCB is 2 radians, so I'm just going to write 2 here and I'm going to write 2 here. Okay, so angle AOC is this, obviously theta is here. So making your method clear, show that theta equals 1.64 to 3 significant figures. So now using this we can't directly find out what we're doing here, can we? But what we can do, right, is we can split them up into 2 triangles, right? We can split it up into 2 triangles. Now what's the benefit of that? So now we know this is half of theta. So I'm just going to write this as theta. It's going to write this as, let me increase. So this will be theta over 2. And now we can work out this angle. How do we do that? So we know, what do we know? We know that we can find this length over here, right? OB from the cosine rule. And then we can use the sine rule to find this angle over here with the 1.4 meters. So the method is that we're going to use the cosine rule. So let's do it here. Let's do it here, over here. So we have to use the cosine rule. So the cosine rule is what? So I'll just remind you, cosine rule is, so it's going to be what? It's usually, so in this scenario we have the side we want, right? So that's OB squared, and then it's both sides squared, so OA squared plus AB squared minus 2 times both of them, so 2 times OA and AB cos of A, right? Those, yeah. All right, so now this is, so if, or you can remember that A squared equals B squared plus C squared minus 2BC cos A. That's also another easy, this is probably what you're more familiar with. All right, so now we're doing that. So now what we can do is we can go straight ahead and substitute in the value that we know. So I'm just going to write here OB equals square root of, so OA squared, so OA is 0.6, so I'm just going to write 0.6 squared plus, so 1.4 squared plus minus 2 times 0.6 times 1.4 cos of 2 radians, and we just square root that, right? So once we put this in the calculator, we will get the square root of that, will give us, so we get a long decimal. So I'm just going to write a couple of values. So 1.73756, and it goes on. And this is in meters. And now we know this, so now we can find the angle of this, right? So I'm going to write, so I'm going to do the sine rule now. So there'll be sine of, I'm just going to write, so this is theta over 2, right? That's what we're trying to do. Over, so this is the opposite side, is 1.4 meters. And we know that sine, this is sine 2 of OB, which is 1.7. I'm just going to 1.73756, this. And now all we need to do is find the this angle over here, right? All we need to find this angle. We need to rearrange and then inverse sine. So how do we do that? So that will be sine theta over 2 equals 1.4 sine 2 all over 1.73756. So theta over 2 will be sine inverse of all this, sine 2 all over 1.73756. So that's that. So that gives us, theta over 2 gives us 0.82219. So now we just do theta is 2 times this, so 2 times goes on, so 2 times 0.82, let's say 2219. This gives us 1.644. So theta equals 1.6423 SF. That's how we. So you always want to get one more plus one more digit, so you can round it off to 3 significant figures. So what did we do here? We did the cos rule to find OB, right? The cos rule to find OB. We use this to find theta over 2 sine rule via the sine rule. That's the method we did here. Alright, so now that's that. We'll now find part B, which is the perimeter. And this is easier, so that was part A. So I'll just write this is part A. So part B, so find the perimeter of this. That is quite simple. So all we need to do is find this length over here. So we need to find this length over here. And if I do this, well, so just this length over here, the arc length, basically the major arc. And how do we do that? We know what theta is, right? So we know the arc length is r theta. So r in this case is 0.6 meters times pi. Now theta, we want the major arc, so that will be 2 pi, take away theta. So theta we know is 1.64. This gives us 2.783 meters. And because we want 2 significant figures, so I'm doing a bit more, so we can just round it at the end. And these are 1.4 meters. This is also 1.4 meters. So all you have to do is, so the perimeter is 2.783 plus 1.4 gives us 2. So this gives us 5.58 meters. So when you round it to 2 sig fix, so perimeter to 2 SF is 5.6 meters. The final answer. Now part C, find the area of the sine in meters squared to 2 significant figures. And that's pretty simple. So we can split it up to 2. We can split it up to 3 actually. 3 areas. So we have the area of the sector plus the area of this triangle, area of this, and area of this triangle. Now this is very simple because we already know 0.6 meters here, and so I'll just highlight this in another color. So we already know 1.6 meter and 0.6 meters and 2 radians. We can apply half AB sine C and then multiply it by 2 because there are 2 triangles. So to simplify this, we can write. So the area is, so the area of sector is half r squared theta. And then we have the area of the kite, right? Area of the kite, right? The kite, which is this kite here, is equivalent to 2 times the area of the triangle. So OAB, for example. Now OAB is this which one? So that is this one, just to reiterate. So that is this triangle here, OAB. Alright, so how do we do this? So simple. So we have, so the total area, right? So I'm just going to write area equals, so half, we know r is 0.6 squared, and this is the major arc, right? So 2 pi minus 1.64, because we want the angle for this, which is 2 pi minus theta, and then plus, now we're talking about the area here. How to find the area? So the area of a triangle is half AB sine C, and we know AB is 0.6 meters and 1.4, and the angle inside is 2. So this will be 2 times half AB, so 0.6 times 1.4 sine 2. So this will give us, so let's do it separately. So the half r squared theta will give us 0.8357 meters squared plus, so this will give us, so 2 times half times 0.6 times 1.4 times sine 2 will give us 0.7638 meters squared. So we get a combined answer of 1.5995 meters squared. So the area of sine, and let's look at the degree of accuracy. They wanted it in 2 significant figures. So area of sine to 2SF is, so you can see over here is 1.6 meters squared. 0.6 meters squared. I'm going to change it to this. So over here, so this is the answer. Area of the sine to 2SF is 1.6 meters squared. Let's move down. We have question number 8. So we have question number 8. Figure 4 shows a sketch of the curve C with the equation y equals 4 plus 12x minus 3x squared. Right, so point M is the maximum, so that's the point M, a turning point on C. Part AI, write 4 plus 12x minus 3x squared in the form, and so this is completing the square, hence or otherwise state the coordinates of M. That's pretty simple, so let's do that. So let's do it here. So part A and then I. So now let's write it as x squared, ax squared minus b plus bx plus c, so that'll be minus 3x squared plus 12x plus 4. So now let's divide everything by 3 to get x squared on its own. So that'll be, so I'll just take minus 3 out, so minus 3, so x squared plus 12 divided by 3 is 4x. So that'll be, so because there's a negative, so I have to go back actually. Because it's a negative, so we're taking negative 3 out, so that'll be, so let's divide by negative 3 actually to get positive. Let me just do, nope. Divide by negative 3. There we go. So that will be, so that will be minus 4x, and then this is already plus, so this will be minus 4 over 3. So now we can complete the square. So that will be, so if you remember, because this is minus 4x, so when you complete the square, that will be half that, so minus 2 whole squared. So minus 2 squared minus 4 over 3. Right? So now 2 squared is 4, so this is equivalent to minus 3 x minus 2 whole squared, so that's minus 16 over 3. And then when you multiply it again, everything by 3, so that will be minus 3 x minus 2 whole squared plus 16. So the form they wanted is a plus b x plus c squared. So the final answer is 16 minus 3x minus 2 whole squared. So this is the final answer. Part II. Part I. So now part II. They want the maximum at M. Now this is the very neat trick that we have here. So this, find M, right? It's pretty simple. Now this usually is the y coordinate over here, and this over here is usually our x coordinate over here. So which is, when you have x minus 2 is something, so this, when it equals something, equal to say 0, x is always 2. So we always take the negative root of, so the negative answer of what's inside the bracket. So the answer will be 216. And is it consistent with what we have here? It looks pretty consistent. You can see this is positive and it's above, so that's 16. So that's our coordinate of M. Because it says hence or otherwise, we can use the previous equation. When it says hence, you can usually take help from previous part. Usually. Alright, so line L1 passes through O, which is center, and M. A line L2 touches C and is parallel to L1. Find an equation for L2. Okay, so now, pretty simple. So let's see. So they're saying it is what? It is parallel, and it only touches C. That means it only touches C probably around, let's say here. That looks pretty parallel to me, but it only touches C. You can see it only touches C. So we want a line that only touches C. And what is that line? That's called a tangent line. We're trying to find the tangent line. Alright, so let's do that. So part B, right? So we know for L1, right, we can see over here that they meet at 0, 0 and at M. So L1, so the points that we have are 0, 0 and M, which is point where 2 is 16 from the previous question. And so let's find the equation. So we can find the gradient first. So M, the change in y over the change in x, that is 16 minus 0 over 2 minus 0, so that is 8, right? And then y equal, so y minus y1, mx bracket x1. So let's say we use these coordinates because 0, 0 not helpful. So y minus 16 equals 8, x minus 2, that is y minus 16 equals 8x minus 16. So y equals to 16 cancels out, so we get 8x. And that's consistent because you can see that the intercept is 0, 0, 0. So our line for L1, right, I'm just going to write L1 line is y equals 8x. Going to box this, so remember. So now we need to find what? A parallel line, right? We need to find a parallel line. Now we remember, right, so the gradient here is 8. So to find a tangent line at 8, what do we need to do? So what do we need to do to find the tangent line? We need to find the gradient. Gradient is equal to 8. We need to find the values for that, right? So we can find a point there, right? So we can find x and y to make or plot the line. So let's box this. So this is also key information to find the tangent line. So what was the equation initially, if you remember? So y equals, we can just scroll up. So y equals 4 plus 12x minus 3x squared. So 4 plus 12x minus 3x squared. So dy over dx, right, is, so 12 minus 6x. And this now equals 8 because we want a line that is parallel, right? Parallel to L1. So we need to get 8. So that's pretty simple. So 12 minus 8 equals 6x. So 6x equals 4. So 4 over 6 is 2 over 3 equals x. So that's our x coordinate. Alright, let's find our y coordinate by this. So y will be at points of 4. So we are substituting into our original function. So 4 plus 12 times 2 over 3 minus 3 times 2 over 3 squared. So that will give us 32 over 3. Okay, so now we have the point of L2. So L2, we have the point 2 over 3 and 32 over 3. And we know the gradient is 8 because it's parallel to L1. So I'm just going to write parallel to L1. So the gradient of L2 will also be, or this the tangent line, right, will also be 8. So this is tangent line, just so you remember, instead of L2. So same thing again. So y minus y1, mx bracket x1. Substitute, so y minus 32 over 3 equals 8x minus 2 over 3. So that'll be y minus 32 over 3. So 8x, so minus 16 over 3. So y equals 8x. So we add 32. So 32 minus 16 is still 16. This is now plus 16 over 3. So our tangent line, our equation for L2, right, which is basically the tangent line, right? So our equation at L2 is y equals 8x plus 16 over 3. So this is our final answer. And let's move on to question number 9. So we're now at question number 9. Figure 5 shows a sketch of the curve with the equation y plus f of x, where f of x is root x and where x is greater than 0. On the next page, there is a copy of figure 5 called diagram 1. This diagram here. We need to sketch and clearly label the graphs of f of 2x, f of 2x, and f of y equals f of x plus 3. Now this is what? This is a translation above by 3. This is like we did in the cause graph. So if you can see the points here, you can see P. So P is 9, 3 here. Now it's going to be 4.5, 3. Going to slightly shift. So let's draw the first one. So I'm going to write f of 2 of x. So let's draw the easier one first. We're gonna first copy this like that. So that's going to be now over here, I'd say, because it's plus 3, so there'll be 9, 6. So let's say over here. So now P is directly above. So that is our y, not y. This is our f of x plus 3. So y equals f of x plus 3. Y equals f of x plus 3. And the point P is 9, but now it's 6 because the y coordinate moved up. So this is for f of 2x. Right? So that'll be what? So our f of 2x will be, so we'll read the same point here. So let's just do like this. So we'll read the same point but faster, like half of it. So now this point P is 4.53. So this is our y equals f of 2x. Alright, so that's that. Yeah, so we have shown on each graph the coordinate of P where it's transformed. So this is the x coordinate divide by 2 here. Alright, so now the graph of y equals f of 2x meets the graph of y equals f of x plus 3 at the point Q. Okay, show that the x coordinate of Q is the solution of this. Alright, so how do we do that? Pretty simple. We just substitute 2x into here, and we also substitute the other part, which is f of x plus 3. So let's do that. So the part B will be, so we'll have root of 2x, right, equal to root of x plus 3. Now root of 2x can be split up into two roots, so that'll be root 2 multiplied by root x, right, equals root x plus 3. So now we can make root x over here in this side, so that'll be root 2 root x minus root x equals 3. Then we can take root x as a common. Root 2 minus 1 equals 3. And then we can write, so root x equals 3 over root 2 minus 1. Now you may be confused and be like, so what do we do now? You may have forgotten what to do here. Now what we need to do is we need to rationalize the denominator. And how do we do that? That's going to be root 2, and we do plus 1 here, root 2 plus 1 here. Alright, so that'll be root x, not 2, root x equals 2. So 3 root 2 plus 1 over here in the denominator, the numerator. So root 2 times root 2 over here is just 2. So 2 minus 1 is just 1. 2 minus 1, which is just 1. So root x root x is equivalent to 3 root 2 plus 1. So that's how we get to that answer. So now part C says, hence find the simplest form of the coordinate q. Now the q is what? We have to square it, right? That's all we have to do. If you remember, we need to find the coordinate, right? So this is the x, we need to find first the x coordinate, right? And then we have to do something. Alright, so now it's part C. So we know that is root x equals what? 3 root 2 plus 1. Now, so x equals 3 root 2 plus 1 whole squared. Right? Whole squared. Now, if you put this in the calculator, you're only going to get a decimal, right? So we have to expand it. So this will be now 3 root 2 plus 3 squared. So now the same thing as saying 3 root 2 plus 3 times 3 root 2 plus 3. And then we can expand it. So that'll be what? So that'll be 9 times 2 plus 6 root 2. No, sorry. That'll be 9 root 2 plus another 9 root 2 plus 9. So that'll be 9 times 2 is 18 plus 9, which is 27 plus 18 root 2. So that's x, right? That's our x value. This is our x value. Now, if you remember, y equals root x, right? And, well, you look at that, root x, and over here, root x is here. So we already know what point q is now. So we can write q is, so the x coordinate is 27 plus 18 root 2. And then we can write, so the y value is 3, or rather 3 root 2 plus 3. So expand it and it's the same. So that's our point Q and that is our answer. Alright, so that is that. Now we go on to question number 10, which is the last question of the paper. So we have a curve has an equation y equals f of x and x is greater than 0. The first differentiation of f of x, and the first differential is ax minus 12x to the power of a third, and f, when you differentiate again, to differentiate twice, equals 0 when x equals 27. And the curve passes to 0.18. So the first question is, find the value of a. That's pretty simple, right? What do we have to do here? So we have to differentiate this. So we differentiate this once more, right? To get what? So to get f dash dash x, right? And then what? And then what do we do? We can sub in 27 because we know that that's when f double dash x, which differentiate twice x, equals 0 is. So let's do that. So part A. So f dash x. So ax squared. ax minus 12x to the power a third. And we differentiate this once more. We will get, so ax will become a. So that'll be minus 12, so a third. And so minus 12 over 3 is minus 4, right? And we take 1 away from the power, so 4x power minus 2 over 3. And then what? We know this is equal to when you add 27, 7, 27. So now we're going to sub in 27. That will be, so this will be now 0 equals a minus 4 27 to the power of minus 2 over 3. So 0 equals a minus 4 over 9. So a equals 4 over 9. So that's our a value, right? So this is 4 over 9. This is our solution for part A. What about part B? So first we have to rewrite what B is, right? So let's write B. How do we find f of x? We have to integrate, right? We have to integrate f not x, no, f differentiate x, which is dx. We have to do this, right, to find f of x. So now first let's rewrite f, the first differentiation of x. which is, now we know what a is now. It's 4 over 9, so we can write 4 over 9x minus 12x to the power third. Now we can integrate this, right? So 4 over 9x is 12x to the third dx, right? So that will be what? So x becomes x to the power 1 becomes plus 1 will be x squared over 2. So 4 over 9, and it's times by what? Times by x squared over 2. And then minus the 12 stays as it is. And then what? So we add 1 becomes x to the power 4 over 3. And we're dividing by 4 over 3. And what? Don't forget the plus c. Very important. Don't forget to add the plus c. So now what? Now we can simplify all this. So that'll be what? That'll be 2x squared over 9. Then what? Then it's minus 9x to the power 4 over 3 plus c. Now this is f of x so far. Are we done here? No, we need to find what c is. Now this is where this comes into play. They give you this information, the third point, bullet point. The curve passes to the point 1 and minus 8. And as soon as you know this, this means that you can sub in. So you can sub in, I'll change the color actually. So we can sub in 1 and minus 8 to find our c, which is over here. So this is over here. So let's do that. Let's sub in. So that'll be, now we can sub in. So that'll be f of 1, right? So 2 over 9, 1 is 1, minus 9 plus c should equal negative 8. So that means, so what does that mean? That means now we can rearrange to find what c is. So c equals 9 minus 8 minus 2 over 9 gives us what c is. Now that is 1 minus 2 over 9, which is 7 over 9. So our final answer is f of x equal to 2x squared over 9 minus 9x to the power 4 over 3 plus 7 over 9. 7 over 9. So now we are done. But what if you wanted to check if you're correct? So if you wanted to check, you can differentiate. Differentiate to see if you get the similar answer from before. So let's say we differentiate for now. Let's say we differentiate. So that'll be f not x. So that'll be 2x squared. So done by 2. So that'll be 4x over 9. And then 9 times 4 over 3. So that's 36 over 3 is minus 12 x to the power of a third. And is this what we got? And this is what we got in the beginning? Yes, we did. You can see over here. That's what we got, right? Over here, this is what we got. F of x, this is what we got. Well, let's say you're not sure, and let's differentiate again. So we'll get what? We'll get 4 over 9 minus what? Minus 4 x to the power minus 2 over 3. And what we can do is we can sub in x equals 27, and we'll get, it should equal 0. So now we can try it. So f dash, so we have 27 with 4 over 9 minus 427 and minus 2 over 3, and that does give us, right, 4 over 9 minus 4 times 1 over 9, which gives us 0. So we can conclude that the final answer is indeed f of x equals 2 over 9x squared minus 9x to the power 4 over 3 plus 7 over 9. So that is our final answer. That is the end of the paper. So be sure to check out the Discord server. In the description below, that'll have this paper and the other papers from before I've done eventually. And I hope to see you again. And this is the end of this paper. Thank you for listening.